Okay, the format that we have set up here, this is using distributive property because of the parentheses that I see. But I don't see a value written in front of the parentheses. So who can remind us, when there is not a number written, what invisible value always exists? Damien? A 1. So in front of each of these parenthesis sets, I can go ahead and write a 1. So I'm going to go ahead and write a 1 in front of this first set. And in a different color, I'm going to go ahead and write a 1 in front of this second set. So each of them has a 1 written in front of it. However, only one of those is going to actually impact the binomial that it's multiplied to. Impact meaning only one of them is going to make a change to the binomial when you distribute it. Which one of these ones is going to actually make a change to the binomial? The first one or the second one? William? Why? Very good. He said the second value of 1 is going to make an impact. It's going to make a difference because of the fact that it has a subtraction sign, making that 1 a negative. So I can still distribute. I can still go ahead and multiply and say, okay, I'm going to do 1 times that 5x and 1 times that 8. But it's still going to stay 5x and plus 8. Nothing changed. It was 5x plus 8 to begin with. It's 5x plus 8 at the end of it. But when I distribute this negative 1, even though, again, we didn't see it, it didn't say that there was a 1 there, but we know that it existed because it's an invisible value. When we distribute that, there is going to be a change. A negative 1 times 2x is now going to become a negative 2x. It originally was a positive. It now becomes a negative. And then same thing here. We're now going to multiply negative 1 times what? Negative 3. Good. Negative 1 times negative 3. So that negative 3 now becomes a positive 3. It now becomes a positive 3. So it changed. We're not leaving right now. It made a change. Okay, from here, we now can go ahead and start doing what we normally do, which is to combine those like terms. So start with the very first term we see. The first term that we see is 5x. When there's notes going on, you're not leaving. Okay? Yeah. We have 5x as our first term. Does 5x have a like term with it? In this entire expression, does it have a like term? Yeah. What's its like term? Negative 2x. Okay, and here, I'll even rewrite this so that they're all closer to each other. Okay, if I rewrite it, I had 5x plus 8 minus the 2x plus the 3. Okay, it's all one single expression now. 5x does have a like term with that negative 2x. So I can rewrite them. Remember, we talked about it. If you're at a party, you're side by side with those that you like. So 5x minus 2x, what is that going to become? What is 5x minus 2x? 3x. Thank you, Brian. Okay, we're going to have 3x. Okay, let's take a look at other terms. We still have other terms. We've got this positive 8. Does it have a friend? Does it have a like term? Yeah, right? A positive 3. Okay, so a positive 8 and a positive 3 is going to come out to a positive 11. Now we're done, right? Now we are finished. We've distributed. We combined like terms. I just want to make sure you guys understand that even if you don't see a value there, if you see parentheses at all, there is distribution occurring. We are actively distributing a value. Sometimes that value might be a positive one. sometimes that value might be a negative one, which will make a change to the binomial. Okay, let's try another one. If we have 4y minus 9 plus 8y plus 2. Okay, what value is going to go in front of both of them? A 1, right? We're going to put a 1 in front of this first one. We're going to put a 1 in front of the second one. Okay, again, we are distributing. When I distribute that 1, when I distribute this first one, is it going to change anything about my binomial? No, because it's positive, right? What about when I distribute this second one? Is it going to make any change? No, because it's also positive. Okay, but I'll still show it to you. I'll still show you that if we do 1 times 4y, it's still going to be 4y. When we do 1 times negative 9, it's still negative 9. Bless me. And then when we distribute this positive 1, when we do 1 times 8y, it's still going to be a positive 8y. And when we do 1 times 2, it's still a positive 2. So we still have the exact same values that we did before. It's just now we're going to go ahead and get rid of the parentheses. But again, the only reason that everything stayed the same is because we were distributing a positive 1. That invisible positive 1 did not impact our binomials. But now we can combine those like terms. 4y has a friend. Who's the friend? 8y, right? Positive 8y. So we can do 4y plus 8y, and that's going to give us 12y. Okay. Negative 9, don't forget that it is a negative, and a positive 12. They are friends. Even though one's negative, the other's positive, they still are constants, so they can be combined. What is negative 9 plus 2? Go ahead, Corey. Good. Negative 7. And then that's it. That's as simplified as it's going to get. Phoenix, are you drawing? Or are you writing this stuff down? Okay. So you are going to have an IXL skill that you're working on for the next 20 minutes. And then we're going to move on to the next lesson. Okay? Okay, so again, perimeter means you're adding all the sides. There's side 1, side 2, side 3. This should look familiar. You've got some parentheses here. That means that we've got some of those invisible 1s in front of it. The good thing is that they're all positive. So if they're all positive, are they changing anything? No. Okay, 1 times 15x is 15x. 1 times negative 8 is negative 8. 1 times negative 9x is negative 9x. 1 times negative 5 is negative 5. And 1 times 7x is positive 7x. Okay, so it really didn't change anything. So now let's combine the like terms. Does 15x have any like terms, any friends? Jordan? Good. Positive 7x, yeah. So we have a 15x, a negative 9x, and a positive 7x. We can combine those together, and that's going to come out to 13x. Okay, what about negative 8? Negative 8 has a friend, right? Negative 5. Negative 8 and negative 5 are friends. So negative 8 and negative 5, when we combine those together, it's negative 13. So there's our final answer. The perimeter of that triangle is 13x minus 3. Okay, so now I'm going to go ahead and teach you a really easy concept. That's why we only have 10 minutes. 10 minutes for this really easy concept of factoring. Factoring is just like undoing distributive property. Like distributive property, we took what was on the outside and multiplied to everything on the inside. With factoring, you're taking what's on the inside and dividing it by a value that you're going to pull out. Okay? So we know that if we're factoring, like if we know we've got 5 times the quantity of 4x plus 7, we know we're taking that 5 and we're multiplying it by 4x, right? 5 times 4x gave us that 20x. And then we're multiplying here 5 times 7. That got us the 35. That's how we did distributive property. Factoring is undoing that distributive property. Okay, by finding your largest common factor or your greatest common factor, essentially your GCF, right? You guys know your GCF, your greatest common factor. So in order to do that, though, you have to know the factors of each of your terms. So in this very first problem, I have 2 terms. I have an 18x. I have an 18x, and I have a 24. We're going to ignore the sign for just a moment. We're not going to worry about the minus sign in this case. We're just going to worry about the numbers. So when we're talking about the factors, when I say I want to know what are the factors of 18, that means I want to know what times what is going to equal 18. And that has a lot of different factors. We're going to start always in numerical order. Start with 1. 1 times 18 will equal 18. What about 2? Can 2 times something equal 18? Yes. What? 2 times? 9. Thank you. It's okay. It's okay. 2 times 9 can equal 18. What about 3? 3 times 6. Good. So 3 times 6 will equal 18. What about 4? Does 4? No. Right? Because 4 times 4 is 16, and then 4 times 5, that's 20. Okay, so that means 5's not going to work either. And then, hey, we go to 6. We already have 6 listed there. So we now have all of our factors listed for 18. I have another number, though. I've got 24. I want to list all of the factors of 24 now. So again, we start with the smallest always. We always go with 1 times 24. Yeah. 2 times 12. Good. What about 3? 3 times 8. Good. 3 times 8. What about 4 times 6? Okay, and then that's it, right? 5 doesn't go into 24. So there's all of our factors here. Now we want to identify the greatest common factor that they share. What's the largest number that 18 and 24 both share as a common factor? Jordan? 6, right? They have a 1 in common. They have a 2 in common. They have a 3 in common. But we want to go with the greatest common factor. So the greatest common factor in this case is the 6. 6 is the largest factor that they both share. So what we're going to do now is we're going to take that 6 and we're going to, instead of multiplying, factoring requires us to divide. Because we're pulling that factor out, Lucas. We're pulling that factor out. So 6 is now going to go outside of our parentheses. And when I do 18x divided by 6, 18x divided by 6, what do you think that's going to give us? 3x. Okay, now again, my minus sign is going to come straight down into my problem. And what do you think 24 divided by 6 gives us? 4, right? It even says it right here. Because 4 times 6 is 24. Okay, so we get a 4. There's our final answer. That is our factored expression. So again, you're just identifying your greatest common factor between your terms, and then you're pulling that factor out, and you divide each of your terms by it, and what's remaining is what goes on the inside. Let's do another one. Okay, we have 21x plus 14. So we're going to identify the factors of 21, and we're going to identify the factors of 14. So let's start with 21. Again, our largest, or our first set should always be 1 times 21. What else?
2 times
Well, is that an even number? No. If it's not even, it's not divisible by 2. 3 times 7. All right. And that's the only factors that we've got. 1 times 21 and 3 times 7. Let's go with 14. Again, starting with our first set, it's always 1 times 14. What else? 2 times 7. Good. 2 times 7. And then that happens to be it. So what's our greatest common factor here? 7. 7 is our greatest common factor. So where am I going to put 7 now? Behind the parentheses, right? Outside of the parentheses. We're going to put it outside. What operation is going to come down is the addition sign, right? My addition sign comes down. And now we're going to take 21x, right? We're going to take that 21x and we're going to divide it by what? 7. We're going to divide it by the greatest common factor. When we do 21x divided by 7, we get 3x. Okay? Then we're going to do the same thing here. We're going to take that 14 and we're going to divide it by the greatest common factor. So we're dividing it by 7 and we get 2. So there is our factored expression. Okay, I want you guys to try the last one on your own. You're identifying your factors. You're going to list out your factors of 12, your factors of 4, and then of 20. Then once you find your greatest common factor, you're going to pull that out. Factors for 4, we've got 1 times 4 and 2 times 2. And then the factors of 20, we've got 1 times 20, 2 times 10, and 4 times 5. Okay, so our greatest common factor here is going to be that 4. 4 is our greatest common factor. So that's the value that gets pulled to the outside. Everything else is going to get divided by the 4. Okay, so when we do 12x divided by 4, we get 3x plus, when we do 4y divided by 4, we're left with just a y, a 1y. If you wanted to put the 1, that's fine, you can, but you don't have to. And when you do 20 divided by 4, that gives you the 5, so we have plus 5. So there's our final answer. 4 times the quantity of 3x plus 1y plus 5. If you did not finish your Delta Math from earlier, or not your Delta Math, sorry, your IXL from earlier, that is your homework. Go ahead and pack up.